Okay, Assalamualaikum. We are from Group F from class PHY110 We'll be presenting about experiment 2 Newton's law of motion. This is our group members. My name is Muzafidania bint Hamza and I will be explaining about the objective, apparatus and conclusion. Next, we have Siti Nur Ashadha binti Kumaruzaman and she will be explain about the procedure of this experiment. And we have Auni Akila binti Pisul and she will show the results of the experiment. And lastly, we have Wan Farah Fazana binti Shahrul Zaman and she will elaborate about the analysis of this experiment. Okay, first, we have the objective. The objective of the experiment of Newton's law of motion is to investigate the relationship between total forces acted on an object with acceleration of the object and to study the Newton's second law of motion. Next, the apparatus. In this experiment, we will be using a PET simulation. Just click this link to operate the simulation.
Assalamualaikum, my name is Siti Nur Ashada and I will present about the procedure of this experiment. For this experiment, the link given in the lab manual are used. This link will forward us into this simulation website, which is the PET Interactive Simulation website. In this website, there will be a simulation shown, which is the force and motion simulation. Press the play button to start the simulation and wait for it to load. This simulation is conducted according to the objective of this experiment, which is to investigate the relationship between total force act on an object with the acceleration of the object, and to study the Newton's second law of motion. When the simulation has completely loaded, it will bring us to this page. Proceed on clicking force graph, and this simulation will be shown. This simulation is the simulation we use for the experiment. For this experiment, we'll be doing the experiment 2 times, which is one to test the friction on ice surface, and the second one is to test the friction on wood surface. Start off with friction on ice surface. First, we need to change the perimeter settings of the simulation. The friction we change into ice surface, which has no frictions. Change the object into small crate. Acceleration graph are added. I also take on force friction and force sum to get the data for these two values. After all the perimeter settings has been set, we entered the data for the force applied for this simulation. For the first data, we use 500 Newton. After entering the force applied, press the play button to begin the simulation. The simulation should be playing, and while the simulation is being played, the data are collected, such as the force applied, force friction, force sum, and the acceleration are being recorded and tabulated. After all the data are recorded, press the Reset All button to reset the simulation. Then proceed on repeating the same steps as before, but only change the value of the force applied. The value we'll be using is 500, 550, 600, 650, and so on. This is repeated for 10 times, and for each value are repeated for 4 times to increase the accuracy of the data we collect. I'll show it again. Enter the force applied, take the force friction and force sum, add in the acceleration graph, use the same friction surface, which is the ice, use the same object, which is the small crate, and press the play button, record all the data we needed, force applied, force friction, force sum, and acceleration, and tabulate in the same graph. After all the data for the experiment on ice surface has been collected, press the Reset All button once again and repeat the same step. Use the same value but only change the friction into wood surface. All the other steps are the same. The object we use is still the small crate. We add an acceleration graph, click on force friction, and for sum, enter the force applied, which is the same value we use as the experiment on ice surface, which is 500, 550, 600, 650, and so on. Also are repeated for 10 times, and each value are repeated for 4 times for the same reason, which is to increase the accuracy of the data we collect. After all this experiment has been done, all the data are being collected and tabulated.
From the result of this table, you can see that we're using a different force starting from 500 Newton to 950 Newton. Then we use the same mass of crate 100 kg. The value of friction force in this result same because we apply the same surface in this experiment. For experiment 1, the value of friction force is negative 294 because we use wood as a surface. And experiment 2, the value of friction force is 0 because we use ice as a surface. So for this experiment, we get a difference of total force and the value of acceleration.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wanufar Fazana binti Syarul Zaman. So now I would like to proceed with the analysis of the lab report. So first question is from the data, plot graph for total force as a function of acceleration for non-friction surface. As you can see here, we have the graph acceleration versus total force, and the graph is linear. The graph is linear. At y-axis, we have acceleration. At x-axis, we have total force. So 1b, total force as a function of acceleration for friction surface. As you can see here, the same graph, but the plotting is different. Acceleration versus total force. And at y-axis, we have acceleration, and x-axis, we have total force. So for question 2, from both graphs, state the relationship between the total force with the acceleration of the object. So the answer is the acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object is increased. Or we can say that the positive linear slope shows that there is a direct linear relationship between acceleration and force. This agrees with the mathematical equation. Since a constant mass is being divided into a large force, acceleration should be increased. So for this question, we can conclude that when the force increases, the acceleration would be increased too. So it will have a linear graph. So question 3, does the graph obeys Newton's second law of motion? Explain. Yes, the graph obeys to the Newton's second law of motion. Newton's second law of motion describes the relationship between force and acceleration. They are directly proportional. If you increase the force applied to an object, the acceleration of that object increases by the same factor. In short, force equals to mass times acceleration. Okay, so for question 4, determine the gradients of the graphs. What do the gradients represent? Explain. So for non-friction graph, we have the gradient is 0.01. And for friction graphs, we have the gradient 0.012. So for both graphs, we have the same gradient, same value of gradient. So slope of force versus acceleration is equal to mass. This represents the slope of the graph when F is the change in force and A is change in acceleration. So the slope any place on the graph is equal to the mass of the body accelerating, which is m. So for this graph, 0.01 is represent the mass of the object. So for question 5, using Newton's second law of motion, prove that the coefficient of kinetic friction between the small crate and the wood surface is 0.3. So this is the formula. We have force X equals to F minus Fk, which is F is force equals to mass times acceleration equals to force minus the kinetic force we have equals to kinetic friction times mg, which is m is mass, g is gravity. So here we use force equals to 500 Newton, small crate equals to 100 kilogram, and the acceleration equals to 2.06 meter per second square. And so we enter the value to the equation. So m mass equals to 100 times A is 2.06 equals to the force here we have 500 minus G. We know the gravity is 9.8. So here we have it become 206 equals to 500 minus 980. So in this equation, we want to find the kinetic friction. Then we calculate it become negative 294 minus 900 equals to negative 980. So the kinetic friction equals to 0.3. So this question needs us to find how we get the kinetic friction equals to 0.3. So here is the solution. So we have kinetic friction equals 0.3. That's all from me. Thank you.
Okay, based on all of the procedures, result and analysis of this experiment, we can conclude that a net force of an object changes its motion. That means the greater the total net force, the greater the acceleration. Second, Newton's second law provides the explanation for the behavior of objects upon unbalanced forces. The unbalanced forces cause the object to accelerate with an acceleration that is directly proportional to the net force and inversely proportional to the mass. That's all from us. Thank you.